All right, today we're going to talk about force problems, which is the application of law of sines and law of cosines. So basically, like I've got two guys here moving a refrigerator. I've got a beefy guy and I've got a wimpy guy, and they're both pushing on the refrigerator. The arrows I've drawn here will kind of show which way they're kind of pushing. And you can see this is a big arrow because beefy here is pushing a lot harder than wimpy. If just wimpy was to push it, the refrigerator would move along this side of this parallelogram like this. And if just beefy was to push it, it would move this way. But since they're both pushing together, what happens is it doesn't go either one of those directions. It travels down the diagonal of the parallelogram. All right, and that's really the essence of what these force problems are talking about. Okay. Two forces act on a single object. At a given angle, the object will move down the diagonal of a parallelogram with both forces as the consecutive sides. So these forces here are vectors, okay? And a vector is a ray showing magnitude and direction. So that's like kind of which way it's going and how long is the side, how long is the ray. Remember, graph of complex numbers, those are vectors. All right, a resultant. That's a vector depicting how an object will move when two forces are applied to it. It's also the diagonal of our parallelogram. So these force parallelograms are going to have, the diagonal will be the resultant. Like, basically, it's like what happened to it. All right, angle of incidence is the angle between the two forces acting on the object. That's some reminder about some stuff for parallelograms here. The consecutive angles of parallelograms are supplementary. Supplementary means they add up to 180. Okay, so you can see here angle DAB plus angle ADC, those are the consecutive angles in that parallelogram, are supplementary. They add up to 180. The angle between force 1 and the resultant is angle DAC. So sometimes it'll be worded like, what's the angle of the first force with the resultant? And that's kind of like this. That's that there. And the angle of incidence is the whole angle down here, D to A to B. Okay, so there's a little bit of a nuance there. Just so you know, DAC and CAB are not congruent. Not congruent. This does not necessarily equal this, unless those forces are exactly the same strength. And then it will wind up kind of like splitting the difference between both of them. All right. So, procedure, draw a parallelogram, label given, and label what is desired with x. And either use law of cosines or law of sines to solve. All right. So two forces of 28 pounds and 41 pounds act on a body so that the angle between the two forces measures 72 degrees. Find to the nearest tenth of a pound the magnitude of the resultant the forces produce. So I have two forces. I have a 28-pound force, and I have a 41-pound force, which is bigger, so I'll draw a longer side of the parallelogram. And the angle between these two forces is 72 degrees for that whole angle. What they want me to find is the magnitude of the resultant. That's going to be the length of this vector. That's the magnitude of the resultant. So that's x. That's what I want to find. All right. And since we're doing law of sines and law of cosines, I don't want to be focusing on parallelograms. I want to be looking at triangles. If this is 41 here, the opposite side is 41. If this is 28, the opposite side is 28. Then you can do like the alternate opposite angles of parallelogram. This whole thing is 72 as well. I don't think that's really going to help me. I'm going to focus on a triangle that has x in it though, right? So it's either going to be the upper triangle here or the lower triangle. I'm going to go with the upper triangle. All right, now I have side and side. And I can actually find this angle right here because of what we said about the consecutive sides of parallelograms. All right, so 180 minus 72 is 108. That's how big this angle is here. Okay, so that's going to be kind of key. That's 108 degrees there. That was a little messy. We'll neaten that up a little bit. 108 right there. Okay, so now I have side angle side. That's going to lead me to believe I should use the law of cosines. My loneliest side here is x, so x squared equals 28 squared plus 41 squared minus 2 times 28 times 41 times the cosine of 108. Now we've been doing law of sines for a couple of days, so The common mistake here will be to put sine of 1 weight in there. And if you're having trouble and you can't get to an answer, check to make sure you use the right trig function. A lot of times that kind of trips some kids up. And actually, I can evaluate this whole left side of the expression, this whole thing, I can kind of evaluate in like one fell swoop. I can do it all at once. 28 squared plus 41 squared minus 2 times 28 times 41 times the cosine of 108 degrees. Make sure your mode is in degrees. I checked earlier, my calculator is in degrees. So I have x squared equals 3,174.503. 3,174.503. And take the square root of both sides here. That happens with a second square root of second with the negative sign is the previous answer. So 56.34. And they want this to the nearest tenth of a pound. Nearest tenth of a pound. So x equals 56.3 pounds. Okay, there's example 1. Okay, in example 2, we have 2 applied forces produce a resultant force of 18.6 pounds. So, I'm going to draw a force parallelogram here, right? We've got 2 forces acting on a body, and we've got this is 15.8 pounds. All right, that means that this is 24.3 because that's the larger force acting on the body, and 15.8 right there. Oop, I'm sorry, and the magnitude of the resultant was not 15.8, it was 18.6. Okay, there we go. So again, I'm going to use the opposite sides of a parallelogram being congruent to say that, okay, this is 24.3. And now I'm going to be able to focus on this triangle up here. The problem is they actually want me to find the angle between the 2 forces, which is this whole angle. That's not part of one of my triangles. However, again, I'm going to keep in mind that the consecutive angles of a parallelogram are supplementary. I'm going to find, this was x, that's what I wanted to find. I'm going to find this guy first. Okay? So what I have here is I have a side, 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 which is going to be law of cosines. 18.6 squared equals 15.8 squared plus 24.3 squared minus 2 times 15.8 times 24.3 times the cosine of y. Now y is not what I want to find, but when I find it, I can then use it to find x. All right, so here we go. I'm going to start evaluating some of this stuff, right? 18.6 squared. 18.6 squared is 345.96. 345.96. And that equals 15.8 squared. 15.8 squared, which is 249.64. Plus, I need 24.3 squared. And I get 590.49, 590 and 49 hundredths. And then minus, now I can multiply 2 times 15.8 times 24.3, 2 times 15.8 times 24.3, and I'm going to get, oh, no, I didn't get it, 2 times 15.8 times 24.3. There we go, that's better. 767.88. All right, 767.88 cosine of y. All right, these two are like terms and can be combined. That other guy, though, isn't. It has a cosine y attached to it. So I'm not going to be able to combine him with those other ones. So I can add 249.64 plus 590.49. All right, there we go. Add those together. You get 840.13. 840.13. And then minus 767.88 cosine y. And that is all still equal to 345 and 96 hundredths. All right, please do not combine these. They are not like terms. What has to happen here is you have to subtract 840 and 1300ths from both sides of this equation. All right, so I'm going to do 345.96 minus 840.13. And you get a negative 494.17 equals a negative 767.88 cosine y. All right, and then to solve this, I'm going to divide both sides by negative 767.88. And I get, negative 494.17 divided by negative 767.88. And I get 0.6436. And to find y, that equals the arc cosine. So y is the arc cosine of 0.6436. Right, so I do second cosine, second answer. There we go. And I'm going to get 49.94. Right, so my y is 49.94. All right, and remember, that's this angle. I want to find x. So I have to take 49.94 and subtract it from 180. Okay, so 180 minus 49.94 is going to give me 130.06, or 130 degrees. All right, so, and that's x equals 180 minus y, and it was 130 degrees. Okay, there we go. So I've got a 130 degree angle there. That doesn't look like a 130 degree angle, but remember, it's not drawn to scale. Okay? Which I guess you can probably see, because the way I've drawn this, my 18.6 looks longer than my 24.3. What really should have happened, I guess, is, it should have been like this, right? That should have been my forced parallelogram. This is 15.8. This one's 24.3. And then this one's a little shorter, it's 18.6. But again, I've said it's not drawn to scale. I always just kind of draw my forced parallelogram that way and go from there. All right. Number 3, resultant force of 162 pounds must be exerted to move a refrigerator. All right, so force parallelogram, resultant force of 162 pounds. If the two applied forces act on the fridge at angles of 43.6 and 38.7. So actually now I know that this bigger angle here, which is across from the larger force, right? This is longer, that's 43.6, and then this smaller one down here is 38.7 across from the smaller force. All right, find the magnitude of each of the applied forces to the nearest tenth of a pound. And I'll find the first one, and I'll leave the second force to you. So this we'll call F sub 1 for first force, F sub 2 for second. All right, alternate interior angles are congruent. So if this is 38.7, this is a parallelogram, right? So this is parallel to this, which means that this must also be 38.7. So now you can see I have angle, side, angle. All right, when I have angle, side, angle, I need to be using the law of sines. All right, so if I want to find F1, I have F1 over the sine of 38.7 equals 162 over the sine of, I need this angle here, don't I? All right, what is that angle? If that's 43.6 and the other one's 38.7, I can add those together. 43.6 plus 38.7. I get that, right? And then I can do 180 minus 82.3. And I'm going to get 97.7. All right, 97.7. Now that's an application of the law of sines, and we've done that several times. So please finish this, okay? And that does it for our force video. All right, finish this and please find F2 as well. All right, the second force as well. Good luck.